nooses, or hypotenuse, whatever, are congruent and either leg. So it could be this leg or it could be the short leg. As long as the hypotenuse and one leg are congruent, you have congruent right triangles. Likewise, if your hypotenuses, whatever it is, are congruent and either of these angles, not the right angle, but the other angles are congruent, then you also have congruent triangles. So hypotenuse leg, hypotenuse angle. And it can be either angle or it can be either leg. And that's true because the Pythagorean theorem makes it true. All right. One, and it would be just from what's already marked. We have HA. And then from what we could also further determine, these are vertical angles, so those are congruent. So I could also say angle, side, angle. So if you were trying to prove these two triangles were congruent, there's two ways here that you go about it. No, because we don't know anything about, we don't have anything marked on the other legs. So we know an angle, we know a hypotenuse, and then because these are vertical, we know the other angle, but that's the extent of what we can know without it being marked. Any questions about that one? Okay. How about this one? Yeah, AAS, because I have angle, angle, side. And then this one? Yeah, because we have the hypotenuse down the center, and it's the same side for both triangles, so it's obviously the same length, so HL. Okay. So any questions on like just looking at the picture and identifying it? Okay. All right, then let's go over this proof. Okay, I've given that angle R and angle T are right angles. That's marked already. So that's given. Okay, angle 3 is congruent to angle 4. All right, so I have right triangles, and I have the angles that are congruent. Because we're a diagonal across here, it's congruent to itself, which is reflexive property. And so then how do I know the two triangles are congruent?
HL or HA?
HA. Because I know 3 and 4. So I have the hypotenuse and I have an angle. If they had told me RQ was congruent to ST, then I would have had HL.
I forgot the word QS.
Yeah. Does that help? Okay. So, but let's label it. When we see these pictures that aren't labeled yet, we want to label them. Angle A is congruent to angle D. So label it because seeing the picture helps. Okay, so that's given. CBD is congruent to BCA. So CBD, that's this one right here, is congruent to BCA. Those two. Okay. What do I have? Okay, let's not look at the, I mean, you've already seen this, but let's just look at the picture for a second. Just looking at the picture, I have an angle, I have another angle. Now, this is a whole triangle, right? Which kind of tells me that these have to be the same because triangles add up to 180. Now, it's not put into the proof, and it should have been, but that tells me those parts are the same, so that gives me this, oh wait, C, B, D. Yeah, so that gives me this whole angle, matches this whole angle. Does that make sense? C, B, D, and B, C, A. So, yeah, so I have angle, 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 but there's no angle, angle, angle.
Does it have something to do
Congruence.
with AEC? Like how that's supplementary?
No.
In their
No.
So
Because we're looking at, the triangles we're looking at are BCA and BCD. Okay, but like I said, I can tell angle, 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 but angle, angle, angle does not give me congruence. But look at this side right here. It would have been highlighted both yellow and green if the green hadn't covered the yellow. That tells me that that's the same side length for both triangles, right?
Because BEC is a triangle between them.
Yeah. So BC is the same as BC because that's reflexive. And so then I have angle, angle, side. Do you see that? Angle, angle, side, angle, angle, side.
Can I put the check in?
Oh yeah, that's fine. Yeah.
This is like crazy. I was looking for this in the wrong place and stop.
Given, right? Now it's already marked. N is congruent to L. Okay? And then JK is congruent to MK. Also given and marked. Now, our possible congruences. We have side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, angle, and hypotenuse, leg. Now, which of these can we eliminate immediately? Yeah, we can eliminate the hypotenuse ones because this is not a right triangle. Now, I have an angle, so I can also eliminate the one with no angles. So now I'm left with side, angle, angle, or angle, angle, side. I have one side, I have one angle. Now I would need to either state that another angle is congruent or another side is congruent. Looking at this picture, what can I say? Just at the picture. What do I know is the same as, like, the same measure or that's congruent on here? We already know that that was given. I meant, like, that's not already given. Like, just by looking at the picture, what can I say for 100% certainty that's not already labeled is the same size?
NK and KL.
I don't know for 100% certainty that those are the same length, right?
JM and NJ. All the way across.
What do I know about these?
They're vertical. So
Vertical, so they're the same, right? Anytime I have these vertical angles, I know they're the same. I don't know 100% that the sides are the same length. I don't have anything that can tell me that they're the same length. They have to either be the same side, like reflexive, or there has to be something that says, like, K is the midpoint of NL to be given. Does that make sense? There has to be some other information for me to know that those sides will be the same length. But vertical angles are always the same. Excuse me. So I'm going to number them. And I'm going to say angle 1 is congruent to angle 2. Because they're vertical.
okay, so you have to create your own labels.
Yeah, well, you can call them JKN and LKM, but it's easier to number them, don't you think? So now I have that the triangles, oops. How do I know they're congruent? I have angle, angle, side, yeah. I can't, those are eliminated. I've got AB is the same length as CB. That was given. And then I check, it's already marked. And I have angle A is the same as angle C. That's already been given. And it's already marked. And then my next given statement is DB bisects angle ABC. That's this angle here. Okay, well, if I call this angle 1 and I call this angle 2, if this has been bisected, what do I know about angle 1 and 2? Yeah, they're the same because that's what bisecting does, right? So I can say angle 1 is the same as angle 2 because of the definition of bisect. Okay, so that tells me this, and then what situation do I have? Well, I've got an angle, and I've got a side.
So you're an ASA?
Yeah, so I can say that the triangles are congruent from angle, angle side angle. Now, it doesn't want us to prove that the triangles are congruent, does it? It wants us to prove that this side and this side are the same. Well, if my triangles are congruent, then aren't all the sides congruent?
Yes.
So I can say AD is congruent to CD because congruent parts are congruent. Did I? Yeah, I did. Okay. That's actually, sorry, it's corresponding parts. If you do that, okay, CP, CTC is corresponding parts of congruent triangles are congruent. So you can use this abbreviation and you don't have to write the whole thing. So once you say, okay, the triangles are congruent, then all the parts are congruent, and you can just say CP, CTC. We have properties of isosceles triangles. Okay, so the legs are the two congruent sides of the triangle. Okay, so if these two sides are congruent, these are the legs. Okay. The vertex angle, sorry, just one F, angle. The vertex angle is the angle between the two legs. So here. The base is the non-congruent side. So this right here is my base. And the base angles are the angles between the legs and the base. So here and here. Okay, so you have two legs, one vertex, one base, two base angles. Now, what we have is if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Okay, so what I'm saying is these two sides are congruent. Opposite is here. Opposite is here. So these legs, or being congruent, makes these angles congruent. I just can't remember how to word it. And then the converse says if two angles of a triangle are congruent, then the sides opposite so basically this is kind of the same idea except backwards. So what I have is that these two angles are congruent, so the legs opposite are congruent. So if you have congruent legs, then you go across, you have congruent angles. If you have congruent angles and you go across, you have congruent legs.
Okay, so like let's say the two bottom legs
Is equilateral only if it is equiangular. Sorry, it should be if and only if. If and. Only if it is equiangular. So all three angles have to be equal for all three sides to be equal. And each angle you guys should know this one. If all the angles are the same, how much are they? Yeah, 60 degrees. So if I have a lovely little equilateral triangle, they're all 60. AC is congruent to AD. AC, AD. Oh, AD. Name two congruent angles. So this is an isosceles triangle right here, right? So if angle ACD, that's this angle here, is congruent to angle D. Because these are the congruent sides, so those are the congruent angles. It's sideways. Stuff like this, yeah. Okay. If BE is the same as BC, here, so we had AC and AD were congruent, right, for problem 1. So I'll do problem 2 in red. BE is congruent to BC. So angles BCE is congruent to angle BEC. That one is congruent to that one. Okay. If angle EBA, that's this angle here, is congruent to angle EAB, that's this angle right here, what are my two congruent sides? It's always going to be opposite, so so that would make this congruent to this. That's also congruent to that other, so I'll leave the red in there. And then finally, I need a new color. What do you think, pink? All right. Angle CED is congruent to angle CDE, which makes which two sides congruent? Yep. We need to find each measure. So we want to find ABC. That's this one right here. How much is that one?
60.
Okay. I want to find EDF. That's this one right here. Well, I know these two are the same, right? So that's going to be the same as this one. Yeah. So that makes that 70 and that 70. Well, if this was 60 and this was 60, this one's just for giggles. Yeah. Okay. Not too bad on these. Okay, if I know that these two angles are the same, that tells me what about these two? Okay. Subtract 2x. Add 10. That's a plus 10, not 110. X x equals 14. If I know what these two sides are, what do I know about these two angles? Right? So 2x plus 3, not squared, times 2. What's it equal? Well, not 180, because there's 90. Because there's 90 left, right? So 4x plus 6 equals 90. Subtract 6. What's x equal?
22.
20. Look at this. We've got statements and reasons. I have CD is the same as CG. CD, same as CG. It's already been labeled. Okay. DE is the same as GF. DE and GF already labeled. Sometimes it helps to go ahead and mark those with color, if that makes it clearer, if that helps. You know what I mean? Sometimes it helps. It might not. Just got to see what works for you. Okay. I want to prove that CE and CF are the same. What do I know about this now? Well, no, if I know these two are the same, what do I know about G and D? They're congruent, right? So angle G is going to be congruent to angle D because of the Isosceles triangle theorem. I'm just going to write that. Okay. That tells me that these are the same. Now, if these are the same, what do I know about these? The sides opposite. Yeah, we'll think about it for a second. If these are the same.
Lines E and F are the same.
Hold on. Wait. They gave me the two sides. Because these are the same length, that makes these the same length because of the triangle theorem, isosceles triangle theorem. Because I now have side, angle, side, I have two triangles that are the same length. And because I have, or congruent, because I have two congruent triangles, congruent or corresponding parts of congruent triangles are congruent. So because these little triangles are congruent, that makes these sides congruent. Does that make sense?
Because they share the same.
Yeah. Sorry I wasn't 100% clear.